the other day about showing that triangles are congruent? Yes. All right. So we showed that triangles are congruent by showing that all of their sides and all of their angles were congruent, right? But there are some postulates that allow us to do that without knowing as much information. So the first one is the side angle side congruence postulate. All right, this does not need to go on your sheet, just in your notes. Right, and this will be abbreviated as SAS, right? Side angle side. So basically what this means is if you have two triangles, right, so it says if two sides and an included angle of one triangle are congruent to the corresponding two sides and included angle of another triangle, then the two triangles are congruent. I'll write that up here in a minute, but let's talk about what it means real quick first. So, two sides, so it means like if this side and this side and this side and this side, and the included angle, listen, pay attention to this part, guys. Included angle has to be the angle between them, right? So look, we have a side, look up, we have side, angle, side. The angle that is congruent has to be between the two congruent sides for this to work, right? So that is enough information to say that triangle ABC is congruent to triangle XYZ. Okay?
Can you do either ones? Either?
Yeah, so like if this side was marked congruent, then we could use angle A. It depends on what sides you have congruent, right? But, okay, so let me put that theorem up here really quickly, like the words. All right, so angle side angle congruence postulates. If two angles and an included side of one triangle are congruent to the corresponding two angles, an included side of another triangle, then two triangles are congruent. So what that means is we have two triangles. So we have H, I, and J, D. All right, so two angles. So 1 and 2. So we have two sets of the corresponding angles congruent and the included side. So the included side is the one between the congruent angles. Right, so look, we have angle, side, angle. The side is between the two angles. Right, that's how angle, side, angle works. Right, so having that information is enough to say that these two triangles are congruent. So we could say triangle DEF is congruent to triangle HIJ. And remember, like before, we've got to pay attention to make sure our corresponding angles are matching up in our congruence statement. All right, so that's really all of the notes we need to do. I want you guys to go ahead and quickly, I'll leave this up for a minute if you're still copying down, but look at page 165 with me real quick. We're going to be doing numbers 7 through 15. So I just want to go over these directions together because it always tends to confuse people. So it says if the triangles can be proved congruent using SAS or ASA, write a valid congruent statement. So if you have enough information in the picture to show that they're congruent by one of those ways, write the congruent statement and tell me if it's side, or angle, side, angle. If there is not, tell me another side or angle that would make it congruent. So like, look at number 9, right? We have 2 equilateral triangles, or what we could assume to be, right? All the angles are congruent, but we don't know anything about the sides. So you could just say that, like, we would have to have that GF is congruent to LK, right? So we need to say any of those 2 corresponding sides would have to be congruent in order to prove that they're congruent. Like, so tell me the piece that's missing that would make it congruent. Does that make sense?
We can pick any side or angle.
Yeah, as long as it will work with side, or angle, side, angle, yes. Okay, so your assignment is page 165, 7 through 15.
All of them?
Yes.